All right, so how many grams of NaCl are needed to produce this solution? And after preparing your solution, so this is part B of, this solution, you accidentally add 100.0 milliliters of pure water to it, so find a new molarity. So how do I do this? Well, for starters, let's just define what molarity is in the first place. Remember that molarity is equal to moles of solute over liters of solution. Solute, kind of, let's just say if I put salt in water, right? Some of the salt is going to dissolve. And the thing that's being dissolved is called the solute. While the thing that's doing the dissolving, in this case, if I put, salt in water, the water is going to do the dissolving. So that's going to be the solution, right? And all this problem is basically saying is that this 0.500 molar NaCl, what this M basically represents is molarity. And this is basically saying, okay, I'm going to have 0.500 moles of NaCl if I scoop out 1 liter, okay? So if I were to take this solution, I get a big spoon, I scoop out 1 liter of the solution, well, I can expect to find 0.500 moles of NaCl. So how do I do this? So I have 0.500 moles of NaCl over 1 liter. Now, the thing is that I like to think about these types of problems as a sort of puzzle, all right? Because the thing is, I'm trying to find out grams, okay? How many grams of sodium chloride? So whatever my answer is, I know that it has to be in grams. So my goal right now is to convert from moles over liters to grams. So how do I do this? Well, for starters, I can get rid of the liter. How do I get rid of the liter in the denominator? Well, notice how I'm trying to find out the grams of sodium chloride that are needed to produce a 250.0 milliliter, 250.0 milliliter of a 0.500 molar NaCl solution. So I know that the 250.0 milliliters, right? Now, if I convert this to liters, in order to convert from milliliters to liters, you divide by 1,000. So if I divide by 1,000, I get 0.250 liters of, this solution, right? Now, I'm going to write 0.250 liters onto here. And notice how the liters cancel out, right? So now I'm only left with moles, okay? Now, how do I get from moles to grams? Well, if I want to get from moles to grams, well, I have to use molar mass. So recall that if I want to find out molar mass, I just have to find out the atomic masses of all the elements inside NaCl. And then all I have to do now is, well, just add up those molar masses and you get the, total molar mass. So in this case, if I want to find out molar mass of NaCl, I look at Na, and it has an atomic mass of about 23. And I also have Cl in NaCl, right? And NaCl, this is about 35.45, right? Weighs about 35.45. So if I add these two numbers together, it's going to be 58.45. And this number expressed in grams represents the molar mass for NaCl. In other words, for every mole of NaCl that I have, it's going to weigh 58.45 grams. That's what it means. That's the molar mass, right? It basically gives you, okay, if I have 1 mole of a certain compound, well, how much is it going to weigh in grams? And that's literally, right, that's all. And notice how the moles cancel out. So, right, once the moles cancel out, well, all I'm left with is grams, right? I see the liters cancel out, the moles cancel out, I'm just left with grams. So if I just multiply all of this together, so 0.5 times 0.25 times 58.45, I get 7.30625. Now, looking back at my original problem, the lowest amount of sig digs, right? Remember to round to the correct amount of sig digs. In this case, this has 3 sig digs, so I'm just going to do 7.31 grams. And that is going to be our answer, okay? So when you're doing these types of problems, I like to kind of treat it as like a puzzle, right? So even if you really don't understand the question, worst case scenario, you just write down your kind of dimensional analysis, right? Where you had the liters and then you have the moles, right? And then all you have to do is try to find a way to somehow convert it into if you need to review on the dimensional analysis. But all right. So what the formula you got to know for this one is M1V1 is equal to M2V2. All right, this is the molarity formula for kind of dilution, okay? So this type of problem is like very common, and it's like, imagine if you have a soup, right? Imagine if you have like a soup, but the problem is that in my soup right over here, it's a little too salty. I added way too much salt in this soup. So what do I do with this thing? I don't want to waste food, man. I don't want to throw this thing out. So what I do is I dilute the soup. What I mean by that is, look at this. All right. So in the first diagram, my soup is way too salty, right? I have way too much salt in my soup. So for every kind of spoonful of water, let's just say this is some sort of spoon. For every spoonful of water that I take from this kind of soup, right, it's going to be way too salty, right? The salt to water ratio is just way too high, right? And I want you to think about this for a second. So remember how we were talking about molarity, right? Remember, molarity is moles over liters. And in this case, in this example right over here, for every kind of liter that I take out of my soup, well, there's way too many moles. There's way too many moles of my solute, right? So what do? I'm going to dilute the soup. And the way I dilute the soup is I add a lot more water, right? I mean, if you want to make a soup less salty, just add more water, right? I mean, that seems like common sense. But, what's happening here is that now this amount of salt is dispersed kind of throughout a greater volume of water. So now when I take a kind of liter of soup out of this pot, well, there's going to be less moles of salt, right? For every liter that I have now, there's going to be less moles of salt because I've diluted it, right? I've increased the volume. So notice how as I increase the volume of my kind of soup thingy, well, my molarity decreases. And notice how as my volume decreases, right, if I were to go from here to here, right, my molarity would increase. So molarity and volume have an inverse relationship, meaning as one increases, the other decreases. Usually when you see things that are proportional, you see the things multiplied out together. Usually when you see things inversely proportional, you'll see those two things kind of multiplied together. But when things are inversely proportional, like let's say, for example, some of the gas laws, so for example, P1 over T1 is equal to P2 over P2. When the things are kind of divided by each other, then it's like proportional. All right. So, I mean, that's just kind of like something to look out for. All right. Anyways, let's get started. So in this case, molarity, this M1 represents your original molarity. So what's my original molarity? Well, my original molarity is 0.500, right? And I'm going to multiply this by my original volume. So what's my original volume? Well, that's 200.0 milliliters. Now this is going to be equal to my new molarity. So if we're trying to find the new molarity, that's going to be my unknown, right? I don't know what my new molarity is. And this new molarity is going to be multiplied by my new volume. So if I originally had 250.0 milliliters and I added 100 milliliters, well, what's my new volume? That's just going to be 350.0 milliliters, right? Because 250 plus 100 gives me 350. Now, I mean, we could just use a calculator for this because I'm a little too lazy. So, you feel what I'm saying? All right, so that's like 125. Divide that by 350. And, rounding to 3 sig digs, I'm just going to get 0.357 molar. And then, NaCl solution. Whatever. And that is going to be our answer.